So for computing a confidence interval, well, again, we can use the t interval to compute the confidence interval using the differences. So it's just like computing a t interval on our calculator. This is the same formula for computing t interval. Let's look at this example. A company claims that its 12-week special exercise program significantly reduces the weight. A random sample of 8 persons was selected, and the following table gives the weights in pounds of those 8 persons before and after the program. So before I go any further, I'm going to fill in another row here that looks at the differences. So what I'll do is I'll subtract before minus after here. So we'll subtract the top column minus the bottom column to get the D. So 180 minus 185 is negative 5. 195 minus 187 is 8. 177 minus 171 is 6. 221 minus 214 is 7. And then 208 minus 208 is 0. 199 minus 194 is 5. 148 minus 150 is negative 2. And then 230 minus 227 is 3. So now we've collected all the differences here in this column, or I should say this row. I'm going to construct a 90% confidence interval for the mean before minus after differences. Okay, so our point estimate would be the mean of this distribution, or of the sample, I should say, which we can easily compute that mean. One way you could do this now is you can enter the data into a list, and that will make it easy to compute any stats that we need for this data. And in this case, actually, it might even be faster to just enter this data really quickly into a list. So I'm going to enter it really quickly now into L1. Okay. And now that I have it entered into L1, I'm going to go to Stat, Calc one variable stats with L1, and it'll give me in particular the mean of that data, which will be 2.75 in this case. So that's our point estimate. So now to compute the critical value, T alpha over 2, I'm going to use inverse T, but what is alpha over 2? Well, let's remember the confidence level from the previous slide was 90%. So alpha would be 1 minus 0.90, so it would be 0.10. So alpha over 2 would be 0.05. In our sample, we had 8 subjects, and so n minus 1 would be 7 that we're going to put here for the degrees of freedom. Okay, so with that we can get our confidence interval, our critical value. So I go to second vars inverse t, 0.05 with 7 degrees of freedom. So that gives me a critical value of 1.894. Imagine maybe it lands right about there. And with that, we can compute the margin of error. Using the sample standard deviation over the square root of n. So T alpha over 2 is what we computed here. As D, well, I computed the stats for the one variable stats for that list of all the D, all the differences, and there the standard deviation was 4.65. So to remind you, where did that come from? Well, I computed the one variable stats for D. For the D that I put into L1. So that gave me that value there. And N was 8 subjects in our sample. Okay, so that can be used to construct our margin of error. And let's see what we would get here. So (1.894) times 4.652 divided by square root of 8. Gives me about 3.115. So then I can use d bar plus or minus e to get my confidence interval. And the d bar that we had was 2.75. So we get a confidence interval here. 2.75 minus 3.115 is negative 3.65 on the lower end. And then on the upper end, 2.75 plus 3.115, 5.865. Okay. Now, does it appear that the weight loss program is effective? So in this case, it looks like mu d could be somewhere in here, but it ranges between negative and positive values. So it's most likely positive, because more of the interval is on the positive side, but it could be negative. So it's most likely positive, but it could be negative. And remember, if it's negative, what that means is that the before minus the after, when I compute the before minus after, if that's negative, that tells me that it actually went up instead of down. So it's most likely positive, which means you did lose weight. But it's possible that it could be negative. So is it effective? Not necessarily. So it's not necessarily effective. And if we look back at the data in the previous slide, we saw that not everyone lost weight. Some people didn't lose any weight, and some people actually gained weight.